Okay, so I'm going to walk you through a diagnostic digital wax up on a patient that I saw a couple weeks ago for a broken front tooth who came in on sick call. So this patient came in with a broken front tooth from a sick call from a combatives injury where he was hit in the face at about 6:30 in the morning. 8 o'clock, he presents to my chair like this, and asking the patient while we're getting him numb what else he would like to get fixed on his front teeth. He'd mentioned he's always wanted his gap fixed. So I get the patient anesthetized and decide, well, let's do a diagnostic digital mock-up to show the patient what this is going to look like. So a quick way to do this is to hit File, Export, and we send this as a DXD over to our InLab software, and we save it to the desktop. Okay. From there, what we'll do is we'll go ahead and we'll open up InLab, and you can see I just have the model color turned off, but this is the patient's case that we would actually see. We have an upper jaw scan, we have a lower jaw scan, and in the chairside software, we created a secondary duplicate model called his biocopy model. They're exactly the same as the upper jaw and the biocopy, but we're going to use this to do our diagnostic digital wax up in InLab. So how do we do that? We go to the admin side of the software, and we're going to wax up 2 teeth. So to wax up 2 teeth, we're going to do them as Pontics. It's going to give us the best control of aesthetics. So we're going to select our 2 teeth we want as Pontics, and then we're going to select tooth 7 and 10 as our distal crown abutments. This is going to trick the software into letting us go ahead and design an anterior wax up. Doesn't matter what type of machine we select, doesn't matter what type of material we select, but we're going to go ahead and put what we have here, and we're going to go ahead and go on to our model phase. So we just want to select the 2 wax up teeth as Pontics, and then the tooth distal to it as a veneer or a crown as our connector. Now the next step that we're going to do is we're going to go ahead and just trim the 2 teeth that we're going to wax up. We're going to use that with the cut software, or the cut tool in the software. We'll double left click to start, single left click to save our progress, and we're going to make sure we cut out just the teeth that we want to work on, staying close to our existing gingival margins. This is going to help us out with our final design. So here we go. Here's our cut. Now we're going to go ahead and replace it. Okay, so when we replace it, this is important because when we do a wax up, we have to work with a closed model. Can't work with this open model. It's not going to give me a very good Pontic. It's going to freak out the software. So we're just going to circle this in as seen here. Just like we're drawing a giant crown margin, but with the replace tool as opposed to the cut tool. We'll click apply, and now we're going to fill in those spaces. Now the reason it's critical to retain our existing gingival margins, we're going to use that as a reference when we create our ovate Pontic to create our full tooth wax up. This is just like we used to do when we would put a denture tooth on a model. We're just doing the same thing digitally. It's pretty straightforward, pretty easy, right? So now we've got some nice ovate Pontics, and now we should have something that's going to create a nice diagnostic digital wax up. We go to the manual registration screen. We can see that our biocopy is still fitting over top of our trimmed upper jaw model. So now from here, we're going to go through all the steps, checking our occlusion, setting our model axis, setting our jawline, and then we're going to go ahead and draw our margins. Now we draw our margins on tooth 7, 10. We're just going to use the manual margin draw, and we're going to draw a Maryland bridge wing. This Maryland bridge wing is going to connect to the tooth on either side. It's important on InLab 22 that we actually have this point touch to go ahead and create our virtual wax up. So we need to make sure it goes into this interproximal space ever so slightly. From there, we're going to go ahead and set our insertion axis. It really doesn't matter what this is. You can have it pretty much whatever you want. We're just going to go ahead and create an insertion axis like this. Okay, for this portion here, it's important, and this is critical when you're doing a diagnostic wax up, is everything goes to 0. Absolutely everything. Okay? If you don't have it set at 0, you're going to end up with issues. Okay, we're going to apply for similar elements. And then on tooth number 8, which is our pontic tooth, okay, we can set this to 0 if we want. We're going to leave the pontic alone except for our gingival spacing. We want this to look like it's coming out of the gingiva. So we want to intersect with the gingival tissue 200 or 2,000 microns deep, which means it'd be coming out of the gingival tissue on a normal bridge, way too much contact. You'd never get it to seat. This is a pretty neat tool to create a really nice diagnostic digital wax up. Apply to similar elements. And now let's go to edit our element. From here, it's going to calculate a proposal. All right, exactly how we want. That's okay in this stage. Once it calculates a proposal, we're going to go back, and we're still waiting for the patient to get numb, right? We're only about 6 minutes into this diagnostic process. So once we move forward, we're going to let the proposal calculate. And I'm going to go into my position tool, okay? Now, this is where it's really cool to have our biocopy, because we're going to take these teeth here, our lateral incisors, and we're going to move them out the way, okay? We don't want these lateral incisors confusing us. We're not using them for anything other than tricking the software into thinking we have some sort of a bridge design. So now we're going to take this tooth here, and we're just going to use our basic biogeneric individual. We're doing a very quick wax up for this patient to show them what it would look like if we close this midline diastema. So we're getting our teeth in the right global position. Overall, that incisal ledge looks nice. Okay. Now all we want to do is we want to take this and we're going to scale this tooth out, start to close that midline diastema. Now, since we have this tooth in the general position we want, we can go ahead and position this central incisor as well. Scale this closed. Okay. And now we're going to go back and we're going to recalculate our restorations. So about 8 minutes in, my patient's starting to get numb. We've got him numb because we know we have to fix at least one tooth. We're waiting on our consent form because he wants to see what his midline diastema is going to look like. So just to show them, walk him through this and show him and say, hey, all right, I don't think we're going to have to do a crown on tooth number 8. I think we can go ahead and get away with just doing some sort of buildup to get a really nice closure of this space. So we're going to make our copy a little bit transparent so I can play with the shape of the tooth underneath and really get this line angle developed how I want it to look. So really close this up. If I think I want to just do a composite buildup and get rid of everything except for that mesial incisal corner. Show them what it's going to look like building that corner out of composite. Get rid of that lingual because we don't need it. And now we'll make our biocopy look normal. Okay, so here is our wax up, how we want our tooth to look. We're going to restore that broken incisal edge, like so. Bring this back ever so slightly. And now I'll tell the patient it's going to look something like this. Here's what I want your final design to look like. Now, this isn't just to show the patient. I'm also going to make the patient a custom athletic mouth guard, so that way they can use it as a soft night guard until I can fabricate a final product for the patient later on. We're going to apply a little bit of anatomy just to really sell the case to the patient, show them what we can do. Create something like that. And overall, we're going to click apply. Now what the computer's telling me right now is it doesn't really like our connectors, which is fine, not a big deal. It's telling me that I've got some invalid bridge connectors. If that happens, again, it's not a big deal. What we're going to do is we'll go ahead and turn off our biocopy. And we need to make sure that our bridge connectors are at least touching, okay? So here on 7 and 8, our bridge connector is touching. Between 8 and 9, it's saying they don't have a valid bridge connector because they don't have a strong enough contact between 8 and 9. So we'll go to our shape tool and we'll move this over. So now I just have an exclamation point, but not an asterisk. Here I have an asterisk because they're not touching. So we'll grab this, we'll grab that. Now sometimes that'll do the trick, all right? So now I have just a minimum cross-section thickness, but I don't have a asterisk anymore. So that's good. So now here's what our final design is going to look like. If I want to create a 3D printed model, we're going to go to our finalize screen. It's telling me I need an adjustment. I'm just going to ignore that warning. We're going to go ahead and hit export. We'll go back to administration and we'll virtually seat our model. Now, because I'm just going to use this for a custom athletic mouth guard, I'm done at this point. I'm going to take this diagnostic model and I can export this directly to my lab software to 3D print. But if you want to be just a little bit more exacting, we want to get rid of some of this stuff here, like these wings, and we want to trim up this gingival tissue and make it so it's a really nice, well-fitting mock-up. What we're going to do is we're going to hit File. We're going to export this as just a low-resolution STL to our desktop, and we saved it as Wax Up. Okay? We're going to take those and we're going to put them into Mesh Mixer. Okay, so we put it into Mesh Mixer. We're going to get something that looks like this. Okay? When we have this file in Mesh Mixer, we have to eliminate the different shells of this model. So we're going to hit Control, and we're going to hit Combine. We're going to make everything into one piece in Mesh Mixer. Now I want to get rid of my wings, okay? So this little spot right here, we can smooth it down. if we want, we can get rid of some of these spots that we don't like. Okay, so we can use the sculpt tool, the brush, we can use the shrink smooth, we can shrink some of these areas down and make things look a little bit better. Once we've done that, we can go with the lasso tool, we can get rid of some of this excess tissue. And this is all done directly on the prime scan. Okay, so with this patient here, we're going to make one more little trim. I hate pieces like that hanging out of my 3D printer. I'm going to discard that. And now the quickest and most simple way to make this into a printed model is we click Edit and Make Solid. It's going to take a minute for it to fill all 6 holes of this restoration, but once it does that, we're on our way to getting a 3D print ready model. So this patient has gone from our existing scan while we're waiting for the patient to get numb. They've gone to a digital diagnostic wax up that's virtually seated, which we can unseat if we want to look at our digital design one more time. So here it is. And we'll go ahead and overlay our bio copy, which shows what our final restoration is going to look like. And in 17 minutes, we have a 3D print ready model where we can get this on the 3D printer and start the print process to making this patient a custom athletic mouth guard. Now you look at this and you think, wow, this does not look very good. It's because we did a fast model calculation. So let's change it to an accurate model calculation, turn up our density and accuracy, and click Update. And once we get that, we'll go ahead and we'll show you our final mouthguard model. So we went ahead and we saved it here. And we'll pull it up. And here it is. So here is our solid, accurate model that is now ready to export and save as our mouthguard model that's ready to 3D print for our patient. So hopefully that makes sense, kind of walks you through the process and gives you a really good basic understanding of how to do a really nice diagnostic digital wax up in InLab, and utilizing Mesh Mixer can create a really nice model all on your prime scan without taking it anywhere else. Hope you enjoyed the video.